Hi, today what we're going to do is do a little bit of experimenting with full wave bridge rectifiers. They use a step down AC, not step down, they're supposed to convert AC to DC by using 4 diodes, which instead of diodes and use LEDs, since LEDs are like diodes instead they light up when current can flow through it, and then when it can't, when it's being blocked, it's off. Which will make it perfectly good experiment with it, since it's done like that. You'll know exactly how it actually works. So you can get a breadboard, or you can do what I did, and solder 4 LEDs in the situation they make a bridge rectifier, and you can see in the middle there's a resistor. That's our load resistor, 4.7 kilo ohms. I'm not sure if it needs to be that high or not, but by test made it was like 10 milliamps or so at the peak voltage of 24 volts AC RMS, and I got like had to be like 3,000 kilo ohms or so. So I decided to put in like 4.7 kilo ohms just to be safe, and it works well. So to build it, you have to follow the schematic. We'll show you the schematic right now. Okay, here's the schematic on how you're going to put it together. Over here is the AC source, which will be a transformer. It has to be a transformer. I'm not going to run it off a house current because it'll be too dangerous then. Then it goes to this diodes here, the LEDs, configured in this same position as they are in this bridge rectifier. This resistor here will be a 4.7 kilo ohm resistor, depending on what voltage you put in it. Will depend on what type of, how big the resistor has to be to put in parallel with it. We'll also put in a capacitor later on, a 10 microfarad. Not going to go very high, so it's not going to have that much of a load. It doesn't have to be that high. And basically that's about it for it, and you'll learn how it works. Because basically each diode only conducts a certain way. It blocks the voltage flow through the other way when it's in the reverse parity. Now when you turn it on, it might look like the LEDs are all lit up at once. They're not. They're on and off 60 times a second. So let's go back and try this, testing it out. Okay, I got it hooked up to the transformer. As you see, it's lit up here. It looks like all of them are lit up. I don't know why it looks like some of them are dim. Could be the cycle. It's all lit up on over here, I see. Could try turning the lights off. That might be it. It might be because it's not that bright. And the lighting in here is kind of making it where the camera can't show it. Well, anyway, let's try turning off the lights. Okay, that helped it a lot. Now you can see that all of them are on, but they're not all on at the same time, because that means that we'd have to forward bias all the resistors, all the LEDs in here, for us to do that. What's happening is that from the camera and our eyes, we cannot tell that they're going on and off at the same time, alternating in the different corners. This is because it's doing it 60 times per second, changing it back and forth. I'm going over to the oscilloscope in a few minutes to show you more about this. But first we're going to go over some stuff with it. I'll keep the lights off because it looks like you can see the LEDs better with the lights off. So then if you have a 9-volt battery or some sort of DC source, you can test out what happens when the polarity goes the opposite way around, which LEDs will light up. They'll show up on there. But when you have hooked up to the AC source, it looks like they're all on. The whole idea is to get the positive and negative half of the cycle be part of a full cycle. That's why they call it a full wave bridge rectifier, because it does the whole wave. It doesn't do half of a wave like with a single diode would. It does the whole wave. That's why it uses 4 of them in to make up a bridge. So now let's go ahead and try experimenting with the battery. As you can see, got it hooked up one way. You got this LED lit. And we have the LED on the corner down here lit. As you can see, they're close to the 2 wires that where AC will be coming in from. That's because of the 2 diodes from the 2 corners will turn on from crisscross from each other. Will turn on, and that there will make it where it'll conduct through, and then it'll have voltage going to your device. At the same time, at both times the same polarity. So if this is positive, and over here must be negative, because I can see the chunks on the LEDs inside the LEDs. They have chunks inside them. That's how you can tell. One way you can tell, and my wire's not making a good connection. But that's how you can tell which way the current will flow through an LED. Now if I take this one out, swap the polarity, carefully without short-circuiting anything. I don't know if you can tell that. I hope you can tell that when I switched it, the opposite LEDs turn on, indicating that the polarity has switched. So now positive's coming from this end, where earlier it was negative coming from this end. And negatives come from that end. Also, you have double the voltage, forward voltage drop across LEDs in a bridge rectifier. That's another thing another disadvantage from it. You have twice the voltage drop. Usually that don't matter, but sometimes it does. When I experiment with the capacitor and stuff and filtering out a load to a capacitor, I believe a 10 microfarad should be plenty, or maybe 100 at the most. I don't want to get too low voltage where my 24 volt AC will overvolt the capacitors. Okay, I have the bridge rectifier hooked up, and it's going, and it's with the capacitors in off position, so it's not hooked up to the capacitor yet. On volts DC, you're getting, it says right there, 31.5 volts. It's probably because it's bouncing around that it can't really tell you how much voltage it has. And that's why it'll change when I put the capacitor, connect the capacitor to it. Now watch as I hook the capacitor to it. Should go down. And bingo, it did. 10 volts down. Now we're at 20 volts, 0.6. Of course, it's negative sign over here means I got the leads wire backwards. That's okay. We know what's gonna come out to. And if you wanna see how I couldn't get my oscilloscope to work, because after Butch knocked the table over and it fell on the floor. The oscilloscope works fine. I think it's my adapter I have on there that lets me hook wires into it broke, and now I can't connect wires into it. I get an connect adapter. One of them banana jack adapters for the probes. So what we'll do instead, we'll turn over to electronic workbench on my computer, and I'll show you how it works with the capacitor connected and not connected. So let's go ahead and do that. Okay, here's what you get with the ripple. Then if I hit the C key, which is assigned to that switch, bingo! A ripple goes away down a lot. It's still there, but it's not that much of a flow going all over the place signal. Not signal that doesn't go all over the place. Rooms where it looks like it's oscillating very much. It looks like it's close to the rail, and it only goes up and down a few millivolts. And you can see over here these LEDs are lighting in every oscillating between different corners. That's what I said about how they work when they're connected to AC signal. One corner goes to two corners on one side lights on one player T, then the other two corners light another player T. Just like I said. This is with a 10 microfarad capacitor. Now if I stop this, change it to 100 microfarad, it should go away pretty well. Let's see how it does with that. And bingo! Oh, it got confused. What did it say for there? Oh, okay. It can't simulate. It must be because it's using LEDs. Must be the reason. Anyway, if you increase the capacitor, the less ripple you'll get. And that's how it basically works. That's how these linear power supplies work. That's what this is called, a linear power supply. It's using a bridge rectifier and a capacitor. It's supposed to filter out this stuff and help make it a clean, smooth signal. Like smooth as a baby's butt, if you want to call it that. So that's it for now. I hope you enjoyed this video. So, hope you build it. Don't forget to check out my store and use coupon code YouTube 2018 to get 4% off of discount on anything in my store. So thanks for watching. If you like it.